In common base amplifiers, the input is applied to emitter and the output is taken from collector. Since in the AC model of the common base circuit we have a resistor in emitter, it seems to be more convenient to use the T model. We can rearrange the circuit like this. If we neglect the RO resistor, the circuit will look exactly similar to the hybrid pi common emitter circuit. But the big difference is that the signal is applied to emitter and base is AC grounded. You have to keep in mind that this is the T model, so the resistance between emitter and base is Re, not R pi. The input resistance of the circuit is emitter resistor in parallel with the small signal Re resistor. And since the small signal Re resistor is much smaller than resistor capital Re, the parallel combination is approximately equal to the value of a small signal Re resistor. Therefore, we can conclude that the input resistance of the common base amplifier is very small. When resistor Ro is available, calculating the input resistance will be more complicated. To do that, I remove the input source Vs and its internal resistance Rs. Then I apply an arbitrary voltage source Vt at the input and calculate its current It. The input resistance is the ratio of Vt over It. On the circuit, you can see that the voltage V pi is equal to minus Vt. So we can define the dependent current source as minus GmVt. Let's apply KCL to the output port. We can rearrange this equation and write the output voltage in terms of Vt. Let's write another KCL at the input port. We can replace Vo with the output voltage expression from the output port KCL. As previously discussed for degenerated common emitter circuit, resistor Ro has a very small effect on the input resistance. So for calculations, we don't consider the effect of Ro on the input resistance. As you see, including Ro makes calculations more complicated. If we ignore resistor Ro, to calculate the output resistance, we can simply use the T model, and the output resistance will be equal to the collector resistor. If the early voltage is not infinite and we need to include resistor Ro in the model, it is simpler to use the hybrid pi model. Let's first calculate resistor R'(O), which is seen from the collector terminal. This circuit is similar to the common emitter circuit with emitter degeneration. So by using our previous knowledge, we can write the expression of R'(O) resistor. And the output resistance Ro is the parallel combination of R'(O) and Rc. If the early voltage is infinite, by using the T model, we can calculate the voltage gain of the circuit similar to what we did for common emitter configuration. First, we write the expression of the output voltage. By applying the voltage divider rule to the input and the source resistances, we can write the relationship between voltages V pi and Vs. So by replacing V pi in the equation of the output voltage, we can find the voltage gain of the common base circuit. We can make some approximations and simplify the voltage gain. The parallel combination of capital Re and a small re is approximately equal to a small re. Now, if the source resistance is much smaller than the small signal Re resistor, this term will approximately be equal to 1, and the voltage gain is simplified to this equation. To include the effect of transistor's output resistance, when calculating the voltage gain, we have to consider the output resistance R'(O) that we calculated earlier. To find the current gain, we need to find the ratio of the output current to the source current. By using the current divider rule at the output port, we can find the output current, which is the load current. We can use another current divider at the input and write V pi in terms of the source current. This is the current gain of a common base amplifier. In most applications, we intend to deliver high current to the load, so resistor Rc is chosen much larger than the load resistance. Also, the parallel combination of resistors small re and capital Re is approximately equal to a small re, which is equal to alpha over Gm. so the current gain of a common base amplifier is slightly less than 1. We can use the voltage gain to calculate current gain of an amplifier. The current gain is the ratio of the output current over the source current. The output current is the output voltage over the load resistor, and the source current is the source voltage over the input and source resistances. Despite the common emitter amplifier, the current and voltage gains of the common base amplifier don't have a negative sign. This means that the output current and voltage of a common base amplifier are in phase with the input current and voltage. Common base amplifiers are useful when the input signal is a current. They are used in cascode configuration. You will get familiar with cascode configuration in future videos.